Continue. Now we have something we call the quadrantal angles. Quadrantal angles that are angles that are not in quadrants. They are on the axes. Okay. Like 0 degrees, 90, 180, 270, and 360. And if we were to go around and go clockwise instead of counterclockwise, 270 would also be negative 90, 180 would be negative 180, 90 would be negative 270, and 0 would also be negative 360. Okay, now, so the quadrantal angles are on the axes. Let's remember this is the unit circle. It's a circle with a radius of 1 unit. So that means these coordinates are real easy to figure out. It's on the circle with a radius of 1, so its x is 1, its y is 0. Up here, it's on the circle with a radius of 1, its x is 0, y is 1. Now we go out here, we're at negative 1, 0, and down here, we're at 0, negative 1. And if we remember from trig last year probably, okay, if we put a triangle on the unit circle, the hypotenuse of that triangle is always going to be the 1. And we have our x and y coordinates. And this is y, this is x. And if this is theta in there, we look at this and we could say cosine theta, which is adjacent over hypotenuse, is going to be x over 1, or is going to be x. And sine theta, which is opposite over hypotenuse, is going to be y over 1, which is y. So if we want to remember information on the unit circle, if we have coordinates, the xy coordinate is equal to the cosine of theta and the sine of theta, or x equals cosine theta and y equals sine of theta. So this is how we're going to determine the trig values of what we call our quadrantal angles. We just look at our x and y coordinates. So our first line, sine of 0. At 0 degrees, our y coordinate is 0. At 90 degrees, our y coordinate's 1. At 180, 0. 270, negative 1. And 360, back to 0. Cosine is the x coordinate. So cosine of 0 is 1. 90 is 0. 180 is negative 1. 270 is 0. And 360, we're back to 1. And then if we remember, tan of theta is opposite over adjacent, which is y over x, which is sine theta over cosine theta. So now we can also do tan of our quadrantal angles. And if we do sine over cosine, we have 0 over 1, which is 0. 1 over 0 is undefined. 0 over negative 1 is 0. Negative 1 over 0 is undefined. And again, 0 over 1 is 0. So there's our chart for our, what we call our quadrantal angles. These two charts, and knowing, yes, memorizing these values in these charts are going to make trig a whole lot easier. Okay. Now, something I quick mentioned before, I think I put it on the special angles chart, was how 30 degrees is pi over 6, and 45 is pi over 4, and 60 is pi over 3. Well, that's because we have different ways we can measure angles. And if you use your calculators and you go to mode, you always have to choose. Are you going to be in degree mode? So that's one way to measure is degrees. And something else we call radians. when we're in higher level math, like pre-calculus, calculus, we want to be in radians. Okay, for this course, we'll probably do a lot more in degrees just because it's easier to remember. It's what we're used to. And the way we convert to go from degrees to radians, we can multiply by our degrees by pi over 180. So for example, 30 degrees times pi over 180. The quick way to do it is just do 30 over 180 and stick pi on top. Reduce 30 over 180, it becomes 1 over 6 with a pi on top. So there's our pi over 6. If we need to go from radians to degrees, we multiply by 180 over pi. So if, for example, we have an angle that's 5 pi over 6 radians, and we want to know how many degrees. Yes, that's one of my dogs barking at the back door. I'll let her in a bit. We multiply by 180 over pi. The pi's cancel out. You can use your calculator, or you could do 6 goes into 6 once. 6 goes into 180 30 times. 5 times 130 is 150 degrees. So those are our conversions. So for a little practice, I'll leave it to you guys to do this section on page 5. Okay, and now let's get into a little bit of the practicing with the exact values. So it says examples. What we want you to do is find the exact value of the expression. Now all of these things could be put in the calculator. You could just type in sine of 60 cosine of 6 times cosine of 60, and the calculator is going to give you an answer. But it's going to give you an answer in decimal form. That is not an exact answer. That's the calculator taking those radical values that we have and fitting it to the screen. We want the exact value. When we say exact value, we mean radical form if it's necessary. You know, sometimes you might get 1/2 or 1 or 2 or 0. But if there's something with a radical in there, we want the radical form. So to find the exact value, the sine of 60 times cosine of 60, well, here's where having our chart from page 4 handy comes in, okay? We need the sine of 60. So that's radical 3 over 2 times the cosine of 60. So times 1/2. Now, how do we multiply these? Well, it's fractions, so you just multiply top times top. So radical 3 times 1 is just radical 3, and the bottoms, 2 times 2, is 4, and that's our answer, radical 3 over 4. Okay, tan 45, go to our table, tan of 45 is 1, plus 4 times the cosine of 30. We go to our table, the cosine of 30 is radical 3 over 2. So this becomes 1 plus, well, what can we do with that? 4 times radical 3 over 2. Don't use the calculator. We want the exact value. This 4 is really over 1. We can reduce fractions. 2 goes into 2 once. 2 goes into 4 twice. Now we multiply. We have 1 plus 2 radical 3. We could put it over 1, but when 1's the denominator, we don't need it. And then don't combine. These are not like terms. This is like saying 1 plus 2x. Not like terms, so we can't combine them. Okay. Now the next page, okay, we threw radians at you guys on page 6. So first thing I would do is convert pi over 4s to degrees. So remember, we could do pi over 4 times 180 over pi. The pi's cancel out. 180 over 4 is 45 degrees. So we have sine of 45 plus cosine of 45. We go back to our chart. Sine of 45 is rad 2 over 2. Cosine of 45 is also rad 2 over 2. Now we have to remember when we add fractions, we need a common denominator, which we have, so we keep that. It's going to be over 2. And rad 2 plus rad 2 is 2 rad 2's. So we have 2 rad 2 over 2. Those can cancel. And that just gives us rad 2 as our answer. Okay. Now let's see, number 5. F of a is 3 sine a. We want f of pi over 2. So that means we're going to do 3 times the sine of pi over 2. Well, pi over 2, again, converting to degrees. The pi's cancel out. We have 90. So it becomes 3 times the sine of 90. Going back to our chart, sine of 90 is 1. So 3 times 1 is 3.